Good morning, everybody. Buenos dias a todos. My name is Julius. It's my first time in FOSDEM, so I'm a little bit excited. Let me tell you some words about me and my company. I've been working in the embedded world since, let's say, more than 25 years. And my company is a small one, but growing one in France, whose name is IoT.BZH. This is us. We are growing. We are 28 engineers. That means that almost a third of my company is here today with me. We are one of the main AGL contributors because we belong to the AGL community. And Walt is there with us today too. As you can see, in the past years, we have provided we are the most influent committer on the AGL code. What I will talk about today is Julius. Julius is a speech recognition engine. The reason and the birth of that project was pretty much due to our CES demo that we have performed in the last month in Las Vegas. We wanted to be able to show a connectionless speech recognition engine that was obviously open source, that was light, that had an activity on GitHub, and was possibly easy to integrate in AGL. So I had to find that one within a short list of available ones. I've taken a look of CMU things, but I have eliminated it basically due to the fact that it was Java code. It's not my favorite language. We wanted also it to run on the boards that we support. For instance, the one from ONSS, but obviously from the one from Intel. The architecture that we have shown in our CS demo was as such. We have shown a boat simulator which was equipped with an autopilot, and this autopilot was receiving speech orders in JSON format that were captured on another PCM device and processed by the lib Julius. To achieve that goal, I have had to hack and to cheat a little bit. After some days of trying to integrate it in an embedded world and to cross-compile it, I have reached the point I have decided to fork the project. At the end of my presentation, all the GitHub links are available, and that presentation, by the way, will be also available on our website when I'm back in the coming days. I list some of the issues that I have to deal with. The most one that was just not cross-compiling, and it was not feasible with the available auto tools because we have been hard-coding things, and the contributors didn't want to give me the original piece of code. Also, within the engine by itself, there was no easy way to interpret the recognition results. I mean, the recognition results basically consist in a recognition tree with some weights. And the user has to deal it by itself in order to compute a recognition score. That didn't sound good to me, and I have decided to improve the Julius library to make that piece of information available in an easier way. Also, by default, Julius is based on a no grammar and a dictionary or more than 320,000 lines. That signifies that it computes a lot, that consumes a lot of CPU load. And also, when you have to choose a word from a list of 300,000, you make mistakes. And you don't want that type of mistakes, for instance, when you do motion control. If you want to play soft music, it's okay if the sound that goes out, that is chosen by the engine, is not the one that we didn't want to listen to. But when you pilot a boat, it's not acceptable. This is an example of the word to phoneme that is part of that huge dictionary. Just like I said, it's not efficient at all. This is just a single file that have been using for our project. The grammar definition is in a standard format, whose name is the BNF, and it always begins with the same thing. At the beginning, you just describe what is a sentence. A sentence begins with a silence. Eventually, this is the H, M, M. It's an hesitation of the people that speaks, and NSE is the end of the sentence. Then you describe the sentence by itself. A sentence is composed of an order, and you can eventually be polite or not, and then the list of orders. With that piece of code, you already understand that the subdictionary will only hold the words that are part of the grammar. So the idea is to replace this huge amount of lines, but just the needed subset, and to extract all the phoneme combination. When I say combination, it's just because for one word, you can have several ways to say that, depending on the accent, depending on the country you are from. And the dictionary was also dealing with that. That's why I have introduced a new format, a new file format, which is a pre-voca one. The voca is the dictionary, the pre-voca is a dictionary without the phonemes, and also a new extension, which is the phrasal verbs. For instance, it's just to try to be a little clearer, it's more efficient for the grammar to recognize get out than just get and then out. But it was not supported by the engine, and I have added this feature. That leads to best recognition results and less false positives. To summarize, the grammar generation goes this way. The user has to create the pre-voca file that is computed to a voca one, and then that tool, which is provided by the Julius suite, computes to a finite state machine, which is a DFA one, and a dictionary in its own format. This is the expected result for the pre-voca to voca computation. The numbers that are acceptable are described here, and at the end, it is missing here, of course, but you got the numbers and every possible combination of phonemes. It's the same for starboard. This is probably the trickiest thing that I had to deal with. Julius didn't support a wake word implementation. A wake word is mandatory for several reasons. The ones that are listed here on that page, but also they can have legal issues to wake word, because in some cases, in some countries, it's not acceptable that the microphone is always on listening to what you are saying. When you have a wake word, you can have sentences integrity. I mean, when you are in the process of recognizing something in the middle of the sentence, the wake word will be ignored. And the opposite, you won't start any recognition until a wake word is recognized. Thus, it saves a lot of CPU load, and also you can dedicate the recognition process to, you can do it with dedicated agents. A conclusion that I that I have reached also by doing some tests is that wake words have to be long enough. It's more efficient, you have better success when, for instance, saying, hey, pilot, than just pilot. For when you have a wake word, you have to, to implement a matching grammar in front of it. In our case, for the boat demo, the only one that I had is a grammar that matched the pilot one, but also I could have rerouted the Alexa wake word to an Alexa voice agent, for instance. Since the wake word is part of a grammar by itself, a grammar which is composed of a single word, which is a wake word by itself, you have to deal with two grammars. That was also a tricky part. Because even if Julius says that reading some pieces of test samples, that it's theoretically possible to dynamically switch a grammar to another one, that seems to be a broken piece of code. To work on that, I have decided to run two recognition instances, one for the wake word and one for my grammar. And the issue was to share the ELSA PCM. I have just made two threads that were switching from one to the other when the wake word process or the sentence success was okay. At the end of the first implementation, I was just alone on my desk with my laptop, and everything worked fine. But as soon as you introduce some more noise, for instance, a crowd, or just people talking a few meters from you, or some music, or some sirens, or whatever you want, you have to deal with noise tolerance. Another noise issue that was really unexpected is that I had been using a microphone that was buggy. The microphone had a bug. And the recognition was really performing badly. In the first case, with two peaks in the spectrum, which were about at 4,000 and 6,000 hertz, the recognition process needed about 30 seconds before being able to decide what was actually speech or music or noise. That was really bad. In the other case, when it's just constant or random noise, the recognition success decreased really dramatically. In that scheme, that I have taken with Audacity from a .wav file capture for the microphone without any transformation, you can see the two peaks that were disturbing the recognition. This is the first and dirty hack that has worked. It has really improved the performances significantly. I had heard about the Speaks LSM module quite a long ago, and I have to admit that I didn't know what it was made for. And by looking at the code and its features, I have seen that it was implementing denoising, which is not as good as they say, but also auto gain control. This is the AGC on. And auto gain control allows you to be more independent from the hardware microphone that you are using. And that's mandatory when you do speech, to have at least that one, the automatic gain control. For the denoise, Speaks just does the best it can. Okay. The best way to deal with that issue is to have really, to perform noise cancellation, is to have a noise model and to use a tool between the microphone and the engine, for instance, SOX. But having a model is not always possible. Even, for instance, when you don't have a quad near you. You have to make some sound samples. The last one is user voice learning. That's something that is available in some speech recognition, for instance, on your OS. But I can see that as really constraining to the user because it's painful. You have to tell about 25 sentences and it's longer. And after that, you have to process that through several files. But that should improve the results a lot. In terms of CPU needs, I was, let's say, disappointed because it worked fine on a laptop, an Intel with 8 cores, but it was quite impossible to make it run properly on an ARM, even if on recent hardware like an Arch 64. You have to leverage the vector calculation. The FPU, for instance, the AVX1 is mandatory. And obviously, on ARM, even if it doesn't perform very well, you have to use the Neon coprocessor as well. An idea to get better results is to use a DSP, which is sometimes available, for instance, on the Renesas hardware. These are the axis of improvements that I wish to work on in the coming months, if people get some interest to it. To implement grammar plugins, what I say by that is that the end application should be able to provide its grammar to Julius. Julius would eventually pre-process it and use it on demand. Also, to look deeper in the dynamic grammar switching recognition, a switching process, because for now it's just a hack, to match Amazon Alexa results templates in order to be compliant with the applications that are already aware of the Amazon API, and also to add in these templates new ones for motion control, because they simply don't exist at the present time. I'm done with our presentation. I will be happy to try to answer to any questions if you've got some ones. Yes?
So actually, two questions. First one is, what about upstreaming your modification to the... I can shout.
No matter how loud you shout, it won't be recorded on the video.
Hello. Oh, yeah. So actually, two questions. First, what about upstreaming your modification to Julius? And the second question is, when will we have a package in Bilroot for that?
In Bilroot? Okay, that's a good question. I will try to answer to the second one first. I really love Bilroot, and it's pretty easy to integrate a package that comes from it. I already have some contribution in Bilroot. Yes, okay. And for the first one, I already have a pull request on Julius, but the maintainers don't have accepted it yet. I have some commits missing on that pull request branch. I will add them. Essentially, the piece of code that computes the results tree to just a sentence and the best score. I think it is useful. It is painless for them to have that code additionally. So, yes.
Thank you.
Yes.
Hi. So my question is, do you have any idea of why?
I can't hear you, so I'm sorry.
Okay.
Due to the noise,
I will wait.
Okay.
maybe. Okay, now better?
Better, yes.
Okay, so why do you think that Julius has that performance problem in other platforms? Is there anything that you have been able to measure or?
Okay. You mean what was my criteria for performances? Yes, okay. I didn't want for instance, 8 cores to be busy for 7 seconds. It's not acceptable. And also, the time of computation was critical in terms of user experience. I mean, I've already been working on HMI interfaces in the past. And by experience, when you wait more than 500 milliseconds, the user says that it's crap. Okay? With speech, let's say that you can be a little more patient. And 1 second be okay, but not 7.
Thank you.
Okay. If you come to Brittany, come to this. Oh, sorry.
I was too late, so you are French speaking, so I have this 5 fingers also, because the vocal connection, the speech connection is different language. It's not problem, because English is not particularly good to forward cognitions.
Yes.
French and Spanish are better. So.
Yes, but there are.
Repeat the question, please.
Okay. Okay. You are asking eventually if it could be possible to add new language to Julius. To have more languages to Julius. Yes. Julius already supports Japanese. They already have Japanese model, and they say that they are compliant. That they are compliant with some dictionary. Language models, with some standards of these models. That's not something that I have been investigating much, but it should be able to add more languages. Okay. Last one.
Hi. At the start of your talk, you showed a table converting words into phonemes, and you obviously had these 325,000 words or so. Where did you obtain that conversion table from, and how did you cope with different variations on standard English for Australian, South African, Scottish, whatever?
The table that has taken is the one that Julius provides as an example. And it's common English with no particular accent. To my mind, if you wanted to really better support accents, for instance, the Australian ones, I don't think that it will work. And in the model that I have shown, you should also be able to completely remove Julius eventually, because I have made a kind of API between an abstraction level between the application and the engine by itself. And I wish, for instance, to be compliant with the nuance one, because I've already seen let's say, what they can do. And I think that's a better solution, even if it's commercial. You will have to pay for that. Okay, time is up for me.